Okay, in this video I'm going to talk about solving separable first-order differential equations. So you may encounter these in usually a Calc 2 or Calc 3 class. You obviously also see them in differential equations classes. And a first-order differential equation is just an equation that basically has a derivative, dy dx, a first derivative, equal to some function involving x's and y's. It's called separable if that function of of differentiable equations, but never hurts to do a couple. So this is the idea. Basically, get all your x's on one side, all your y's on the other, and integrate. You want your dx's out of the denominator. So the first thing, I'm going to multiply both sides of this by my d. So I'm going to divide both sides by x squared plus 1 by x squared plus 1. I'm also going to divide both sides by y at the same time. On the left side, then, I'll be left with 1 over y dy. And then on the right side, I'm left with x over x squared plus 1 dx. Okay, and again, with a differential equation, all you're basically trying to one side or the other. To integrate the right side, I would have to do a u substitution. I would let u equal x squared plus 1. Du would be 2x dx. So then I would get 1/2 du equals x dx. So then when I go to integrate, it says really I'm going to be integrating, well, x dx is replaced by the 1/2 du, and then I'm just going to have 1 over u left over of u, but remember u is x squared plus 1 plus c. Now, if possible, usually what you'll do on these is try to, again, get it in terms of y. Okay, so I'm going to get this in terms of y here real quick. And remember, to get rid of natural logarithms, you exponentiate both sides. So I'm going to take e raised to the natural logarithm of y, and then I'm going to take e raised to the 1/2 natural logarithm of x squared plus 1 plus c, so we'll be left with absolute value of y equals, remember the other trick too, you can bring coefficients up as exponents on logarithms. So really I'll have the logarithm, but the exponent of 1/2 will turn into a square root. So I'll have the natural logarithm of x squared plus 1. I could write this times e raised to the c. Okay, so I could have written it as e to the part times the e to the c, right? I could have written this as e to the 1/2 the natural logarithm of x squared plus 1 times e to the 1/2 of the natural logarithm. But again, the 1/2 is going up as an exponent, which is a square root. There's my e to the c still left over. A lot of times, I don't know, book square root of x squared plus 1. Absolute value of y, where a equals e to the c. Alright, and that would be your solution in this case. Okay, so the idea is you basically separate them out and just integrate each side individually. So I'm going to do another one similar to this, a little more complicated just because the integration is a little more complicated.